This video is going to show you how you could make Holt and Winters method forecasting in R. In this particular video, we are going to be working with a different data set called gas electric. Um, it is going to look like this. You do have this Excel file. Make sure to be able to locate it on your computer. What we have here, we do have specific months here for 2 years, starting from January to December, and again, January to December. We do have gas use column, electric use column. We're going to be making a forecast for each of these columns, okay? That's what we're going to be working on in this video. Holt and Winters method function can also be found in forecast package, and you already installed it at this point, and you already loaded it by calling library in parentheses forecast. Okay, so let's import this Excel file first. It is from Excel, and let's specify it. Yep. Make sure that the name appears as gas electric. Okay, it is imported. It is a data frame in R now. Let's type class gas electric to specify what kind of class it is. So it is a table, it's a data frame. Before we jump into Holt and Winters method, one thing that you should always do if you would like to use Holt's Winters function right over here is to convert your data into time series, okay? And the TS function is out there to do just that. If you give a data frame column into it and give other statistics like frequency and start parameter, it's going to convert it into time series. So we can specify, you can look at the help objective, help menu item of the TS function here. It's going to bring up all the details here. But it's very simple. You will see that it's going to be very easily implemented here. So let's take a look at our gas electric data set one more time in data frame. You see that it has a month column, it has a gas use column, and it has an electric use column. I'm going to be first working on the gas use column, okay? And I'm going to be converting this column into time series in R. So TS function is going to return a time series whose name is going to be TS gas. Again, this name is just something that I specify, it can be anything. It is going to include the data frame column into it, right, on the first spot. And it's how I call the data frame column, gas use, right? And it's going to be requesting a frequency here. Frequency is very important in time series. It's basically asking, how frequently your data is being collected. And it is 12 because it is indicated that, in every 12, rows, this data belongs to a different time period, right? So I do have 12 months and I do have another 12 months for the next year, for the second year. And hopefully if I would like to make a forecast, I can make another forecast for the next time, for the next months, right? That's why I specified 12 here. And if you have a year data, let's say you have 365 days, let's say weather temperature that you like to make a forecast for, then you can just specify 365 here. If you have weekly data, then it is going to be 52. Okay. And for the start parameter, just to indicate year one and month one, as you can see, C is a vector. It is basically telling me that I am going to be starting from year one and on the first month. Okay, R is going to understand this, and you see how. So start is also important, and frequency is important. If you enter these two, you can call and execute this line. You create your own time series data here. Let's see what it looks like. Okay, it looks like exactly this, and it looks not really different than what I already have in the data frame. But the important thing is that its class is time series. This is important because Holt's Winters function is only going to be working on time series again. So if you just copy this data frame column inside Holt Winters function, it's going to give you an error. That's why we convert it into time series. So let's plot this time series. Okay, it looks like this. So it has certain characteristics into it. So in the middle of the year, your gas use goes down. Of course, it is actually summer months, right? And in winter months, it goes up. And again, in year two, your gas use goes down and it is going up. So Holt and Winters method, it's very good at capturing these kind of seasonalities. And especially if you have also trend, let's say this trend is also increasing, and with this seasonality, it is also going to be doing a great job capturing that increasing or decreasing trend along with the seasonality. So in your data set, if you do see a trend and seasonality, Holt and Winters method might be your key. Okay, so after you plotted this and see what your data looks like, let's call Holt Winters method and specify the time series that we would like to predict for the future into it. So it's going to be feeding these 2 years worth of data into Holt and Winters function. It's going to be storing it as Holt Winters gas object. Again, this is the name that I specify. You can change this name to whatever you want. Let's hit comment and enter. Okay, it created my model. It created my Humber HV HW gas data frame. It has a lot of parameters into it. You don't need to worry about it. Let's take a look at what this Holt Winters object looks like by plotting it. Okay, I will execute now this line simply. If you look carefully here to this graph, what you see here is this black line is actually the real data that you have. And this red line is basically the forecast the Holt and Winters method or function just worked out for you. Look how close these are. And these are good forecasts. And although this is the training data, it mimics the training data very well. Okay, so that's a good sign. Let's make a forecast with it, right? So let's call forecast function, and again the forecast object that we just created here with Holt Winters function for the next. Actually, we worked on the 10 months, in moving averages and exponential smoothness function, but here let's specify it for the next year. Let's see if it works. Okay. It is going to be keeping these forecasts under next year gas, and let's display it. Okay, so for year 3, it actually names the months for me as well, and see what these 4 point forecasts are, and they're lower and higher, 80% and 95% confidence interval. Well, numbers, they don't really mean that much. We are going to plot them later on, but let's take a look at the accuracy. Well, accuracy on the training set, as you can see, the mean absolute percentage error is very small. Well, actually, this is relative, but I mean, it is less than 10. For sure, it's a good thing. And let's take a look at the plot to see how closely it mimics my current data. Well, if you plot this comment in leading line 87, it is basically going to plot the actual data for the 2 years, and also your data for year 3. So this blue is literally the forecast that you made with the Holt and Winters method. See how closely it represents your seasonality in your data. Okay, it is a really nice method. Again, as I said, if you have seasonality in your data and if you do have a certain trend in your data, Holt and Winters method might work very well for you. Well, what we are going to be doing is, if you remember, we worked on only the gas column. Okay, now we're going to be working on the electric use. We are going to be doing the same thing. We will first convert this into time series, the electric use column into time series electric object. So it will look like this. It captured the first 2 years. It's plotted to see what it looks like. There is a certain trend here, right? So as you increase the time, you do have a positive trend, and you do have seasonality. Let's see how well this Holt and Winters method is going to work out for us. Let's create the Holt and Winters function and feed the time series that we just created into it. Let's execute this line and let's plot it. So this is year 2 only. Looks like my red line is my forecast and my black line is my current actual data. Looks like it is mimicking it right very closely. Let's make a forecast for year 3. Okay, this is Nixie Electric, and let's display it. You can find the table with numbers. Let's take a look at the accuracy. Maybe is even lower here. It is 2.4 on the training data, and let's plot it to see how it looks like. I think it does a good job. So as you can see, so year one, year two, and year three is mimicking the positive trend. In addition, it is also representing your seasonality well in the data. Okay. This is how you could make Holt and Winters forecast functions, how you can use Holt and Winters function in R to make a forecast for your data, especially if you have a positive or negative trend with seasonality.